When we think about blood, we probably just picture a simple red liquid, right? But it's so much more than that. It's basically one of the most complex and essential organs in your entire body. It's our transport system, our defense force, our internal thermostat. But the really fascinating part? Your blood is also a completely unique biological signature, kind of like an identity card that's written in proteins and sugars.
And that gets us to the big question we're tackling here. A blood transfusion is meant to save a life, so why can it be so incredibly dangerous if you get the wrong type? It's a biological gamble where the stakes are literally life and death. To figure that out, we've got to solve a medical mystery that had doctors stumped for centuries.
For a long time, transfusions were basically Russian roulette. Sometimes they worked, but way too often they ended in total disaster. The hero of this story is an Austrian scientist, Karl Landsteiner. Around 1901, he was mixing blood samples and noticed something strange. Sometimes the red blood cells would just clump together. He realized this wasn't random at all. It was a system. His discovery of the ABO blood groups transformed a deadly gamble into a life-saving science, and yeah, he absolutely earned that Nobel Prize for it.
So, what exactly was this system Landsteiner figured out? Well, it turns out our blood has this incredibly smart security system. And to really get how blood types work, you need to meet the two key players, the identity markers and the security guards.
Okay, first up, you've got antigens. The easiest way to think about them as is tiny little ID cards that sit on the surface of every one of your red blood cells. These molecules are constantly telling your immune system, hey, I'm part of this body, I belong here, I'm self. They are absolutely key for your body to recognize what's supposed to be there and what isn't.
So, if the antigens are the ID cards, then the antibodies are the super-vigilant security guards floating around in your blood plasma. Their entire job is to patrol your bloodstream, checking every single ID card they come across. And if they find one that's foreign, a non-self antigen, they immediately sound the alarm and launch a full-scale attack.
And this is where it all comes together, this core conflict between self and non-self. You've got the antigens on your cells that act as your ID, and then you have the antibodies in your plasma, always on the lookout for anything that's not you. Now here's the crucial part. Your body builds a whole army of antibodies designed specifically to attack the antigens your own red blood cells don't have. That one rule is the key to everything about blood compatibility.
All right, now that we've got the players down, the ID cards and the security guards, let's see how they create the two main systems we all know, the famous ABO system and that little R factor that gives you the plus or minus at the end.
The logic here is actually pretty cool and follows that one rule perfectly. If your blood is type A, it means you have A antigens, so your body creates anti-B antibodies. If you're type B, you have B antigens, and so you make anti-A antibodies. See the pattern? It always makes antibodies for what it doesn't have. Now look at type AB. It has both A and B antigens, so it doesn't need to make any antibodies to them. It's cool with both. And then there's type O. It has no A or B antigens on its cells, so it sees both as foreign and makes antibodies against both of them. It's a beautifully simple and totally vital system.
But wait, there's one more piece to the puzzle. On top of the ABO system, there's another major ID marker, the Rh factor. It's just another protein called RhD, and it was first found in rhesus monkeys. That's actually where the Rh comes from. It's really straightforward. If your red blood cells have this protein, you're Rh positive. If they don't, you're Rh negative. It's a simple yes or no question that adds another critical layer to your blood's identity. Okay, so we've got antigens, antibodies, the ABO system, and the Rh factor. With all that, we can finally establish the life-saving rules for mixing blood safely. This is where all that science really pays off.
So let's walk through what happens when things go horribly wrong. Imagine a type A patient gets a transfusion of type B blood. Immediately, that patient's anti-B security guards, their antibodies, spot the foreign B antigens on those donated cells. They attack, causing the foreign blood to clump up. This is called agglutination. And these clumps are disastrous. They block tiny blood vessels, which starves organs of oxygen and can lead to kidney failure, shock, and, very often, death. This is exactly why a mismatch is so incredibly dangerous.
Now, for the interesting exceptions, starting with the person everyone calls the universal recipient, someone with type AB positive blood. Think about it. Because their own blood already has A, B, and the Rh antigens, their body doesn't produce any of the corresponding antibodies. Their immune system is totally tolerant. You can give them pretty much any type of red blood cell, and their internal security system just won't sound the alarm.
But here's the catch. This amazingly receptive blood type is also one of the rarest. We're talking less than 4% of the population. So while they're lucky enough to receive from almost anyone, they can really only donate their red blood cells to other AB+ people, which makes their blood a lot less versatile for giving.
So what about the opposite? The blood you give in a chaotic emergency when there's no time to figure out a patient's type? That would be the hero of the ER, type O negative. O negative red blood cells are like ghosts to the immune system. They have no A antigens, no B antigens, and no Rh antigens on their surface. There are simply no ID cards for a recipient's antibody security force to spot and attack.
And that makes it the universal donor for red blood cells. In a trauma situation, when every single second counts, O negative is what doctors reach for. It's the safest bet because it can sneak past almost any recipient security system, making it an absolute cornerstone of emergency medicine.
But understanding your blood type isn't just about transfusions. This biological identity has these profound implications that stretch across so many different fields of medicine and science.
The exact same antigen-antibody conflict is critical in organ transplants to prevent rejection. It's also vital during pregnancy, especially if you have an Rh-negative mother carrying an Rh-positive baby. In forensics, it can help place or eliminate suspects at a crime scene. And now, research is even finding links between certain blood types and our risk for different diseases. It really is a fundamental part of our biology.
So, it all brings us back to a really personal question. This whole system, discovered just over a century ago, is flowing through your veins as we speak. It's more than just a letter and a plus or minus sign. It's a core piece of who you are. And knowing it isn't just random trivia. It's essential information about your own body that, who knows, could even save your life one day. So, do you know yours?